Hello wonderful person, this is Anton, and in today's video I wanted to do a bit of an experiment, and the experiment is going to be in regards to replacing the atmosphere of Earth and Mars with the atmosphere of Venus that Mars is about to collide into because I didn't place them in a very stable orbit. And we're going to do this, oh look at that, it totally escaped. We're going to do this using Universe Sandbox², and we're actually going to talk about why we're doing this as well. Welcome to What the Math. And so it looks like Mars is about to collide with Earth because once again I didn't place them into stable orbits, and boom, there you go. So we're going to actually talk about these three, or I guess now it's two beautiful planets, because they actually used to be very similar. When they were just created, all three of them were actually very similar. They were basically terrestrial planets with quite a lot of liquid water on the surface. So this right here is Venus, and right there is Mars. And they basically looked practically similar, except for, of course, the total mass or total size. Earth was the biggest, Venus was the second biggest, and Mars was the third biggest. And they also had very similar atmospheric composition as well. Basically, they all kind of sort of terraformed, or very terrestrial in their appearance and their composition. But then something happened, and Earth remained terraformed, or Earth-like, whereas Venus became very hostile and Mars became very barren. And so today what I actually wanted to explore is the idea of what happened on Venus, the so-called runaway greenhouse effect that created Venus as we know it today, basically a very hostile, very highly pressurized, very acidic, and also super hot world. It may actually happen to Earth one day, and it may have happened or could have happened to Mars, but it didn't. And we're going to see what Mars would have looked like and what Earth might look like in the future if this kind of an effect does occur on our planet and on Mars. So let's go into the main simulation here, so-called solar system simulation, and take a look at Venus. So this is what Venus looks like, and this is, let me show you the Venus without the atmosphere so you can actually see the surface as well. So this is Venus's surface. Now, Venus is obviously a very hot, very hostile, very dry world, and I've talked about why it lost all of its water and all of its other materials in one of the previous videos that you can find right here. But Earth obviously doesn't look like that because most of our carbon is essentially hidden inside the lithosphere, inside the ground. But Earth has almost exactly the same amount of carbon as Venus does, and possibly even more. And so let's start with our beautiful planet Earth, and so let's imagine that all of the carbon decides to escape into the atmosphere and re-enters as atmospheric carbon dioxide, not the lithospheric carbon. And if you watched one of the previous videos where I talked about how much there is, it's actually something like 6 or 5 times 10 to the power of 21 kilograms. Unfortunately, in this game, we can't really enter this much. There's actually a limit, so we're going to enter as much as we can. We're going to go into carbon dioxide right here. And I'm going to select, well, let's just select this. This is the maximum you can get. 2.11 times, or 2.13 times 10 to the power of 18 kilograms of carbon. So that's about 1,000 or close to 1,000 times less than what we really have. So we're going to maybe make an assumption that not all of the carbon escaped just yet. Some of it is still stuck inside Earth, and it's going to escape later. Let's take a look at the surface temperature and also obviously the actual surface of the planet and see what happens. So within a few years, or I guess within a few months even, or even days in this case, everything starts to basically increase in temperature. I'm going to actually zoom out a little bit and just run this for a few months. And as you can see, the temperature starts climbing dramatically. Now, it's already like 5 degrees or even 10 degrees above what it used to be. And this is only months after, so essentially it wouldn't take long, if suddenly all of the carbon escaped into the atmosphere, it wouldn't take long for the planet to really warm up to the point where it becomes super hot. Now, so we're gonna wait a little bit, we'll probably wait a few years, so it's 2015 right now, we're going to wait a few years and see how hot it gets if we have this much carbon in the atmosphere. And so about 4 years later, the temperature is already at 58 degrees Celsius. It's basically something like 40 degrees above what it used to be. And if we look at the surface, it's kind of getting dry and hot. So no snow caps anywhere anymore. The sea level has probably covered most of the areas that used to not have sea in them. And so here, this is basically a planet that's already going to be very difficult to live on. Mostly because it's going to be very, very hot, but also because the water levels have actually increased dramatically. And the fact that the water levels have increased will also increase the atmospheric water vapor, which will further increase the temperature even more. But we're going to need to run this for a few more years just to see where it actually settles. And within 15 years, this is what starts happening. You can kind of see that there's actually seasons still on the planet, but every year, the winter and the summer become hotter and hotter and hotter. And we're currently at the average temperature of about 80 degrees Celsius. And it's basically kind of slowly flattening out. And I think it might actually stop at about 85 to 90 degrees Celsius. But that's of course because I actually didn't put all of the carbon that we have into the atmosphere. If I were to put the entire amount of carbon, it would probably be even hotter than Venus. So it might actually be at something like 400 to 500 degrees Celsius. But this is essentially what would happen to our planet Earth if a lot of the carbon decided to basically leave the lithosphere, leave the rock, and be introduced into the actual atmosphere. So this is kind of what may actually happen to our planet if suddenly the water starts disappearing, because that's essentially how Venus became so hot as well. Alright, so we've talked a little bit about Earth, but now let's go to Mars and make this a little bit more extreme, because Mars will actually allow us to insert the entire amount of the greenhouse here, and basically all of the carbon can go into its atmosphere. Right now, Mars basically has very small atmosphere of about 0.6% or less than 1% of the atmosphere on Earth. But if suddenly somehow Mars actually received the amount of carbon that Venus has, and all of this carbon actually entered the Martian atmosphere, this is what would actually happen. Oh, and by the way, Mars doesn't actually have enough carbon to do all of this. It lost its carbon a long time ago. Most of it probably escaped into the outer space because Mars just doesn't have enough gravity to hold on to some of these atmospheric molecules, and also because Sun always constantly interacts with the Martian atmosphere and actually strips Martian atmosphere of a lot of different molecules. This is probably how Mars lost not only water, but of course carbon dioxide as well. So anyway, so let's actually do this. We're going to give Mars 5 times 10 to the power of 20 kilograms of atmosphere, and basically most of this will be carbon. And look at that, look at the greenhouse effect here. It's over 860 degrees. And let's look at the Martian temperature. We're going to basically change this so we can actually see it, and look at what happens to Mars. So I'm going to put the graph right here so you can actually see everything, and we're just going to look at the surface of Mars. Now the thing is, you won't really see much difference other than the ice caps disappearing. But if we actually to put a little bit of water here just for fun, because we want to actually just see the effects that will occur here, so let's just put a little bit of water on the Martian surface so you can actually see what happens as the temperature increases. Now we're currently at over 100 degrees Celsius already, and it only took, I think it only took a few days actually. And this is actually what may have happened to Mars had it been more massive. If it had a little bit more mass, if it was a little bit bigger, it would definitely turn into a kind of a Venus as well. It would be a very hot world. And so the water I just inserted is already gone, but for some reason we still have the ice caps. I think this is probably just a little bug in the game. But you can see the surface of Mars is no longer red. It's actually turning into this scorched brown color. That's because it's getting to the temperatures of 200 degrees Celsius. I'm going to wait a little bit more, and you'll actually probably start seeing like fiery volcanoes on the surface here any second now, because it's getting to the temperature where things will start melting and they will start basically getting really hot on the surface. Now, within the same year, the temperature has actually increased by over 400 degrees Celsius, and the colors on Mars are actually changing as well. It's turning more brownish, more dark, and I think if I were to accelerate this a little bit, it would also start acquiring a lot of different fiery looking things on the surface here. And it took less than a year for Mars to dramatically change in its entirety. Basically, it's now a lot darker, it's more brown, it's almost black actually, and it has a lot of these like fiery looking volcanoes everywhere. It's basically the burning of different gases and also the melting and burning of various surface features as well, and of course possibly volcanoes that are erupting and creating all kinds of fire here. But we're not done increasing temperature here. It's actually going to go up even more, so Mars will transform dramatically. Basically, if Mars had the amount of carbon that Venus has, and if it all was released as atmospheric carbon dioxide, Mars would eventually turn into this beautiful fireball that you see in front of you. So the temperature actually stabilized and even went down a little bit for some reason. But basically, this is what we have now. Even though there's still these caps on top here, that's obviously a bug. But anyway, so this is what Mars would look like if it actually had a Venusian atmosphere, and if it actually had as much carbon as Venus does. It would be even hotter than Venus. It would actually become even more fiery hot, and that's because of one thing. It's because it's actually smaller in size than Venus, and so if we actually add the same atmosphere as Venus has, same amount of carbon as what Venus has, it would actually have higher atmospheric pressure and obviously much higher greenhouse effect as well, which is why Mars has become even hotter. So there you go. So this is what would happen if suddenly both Earth and Mars decided to actually switch atmospheres with Venus. And so this kind of gives you an idea of why carbon dioxide is so important for our planet. Basically, we need to maintain the balance between having a lot of carbon dioxide or little carbon dioxide, because if we were to increase carbon dioxide amounts on our planet Earth, the temperature would also increase as well. And as the temperature increases, the water evaporates and increases the greenhouse effect even further. And at some point, if there's actually no water left on the surface at all, that's when the plate tectonics would stop working. They would stop basically moving around, and a lot of the carbon inside the lithosphere would actually be released again, and this would create a fire Earth, an Earth that is actually a fireball. And yeah, good luck surviving here, because, you know, it's hot. Anyway, hopefully you learned something from this video, and hopefully now you know a little bit more about carbon dioxide, greenhouse effect, and the effects it has on various planets in our solar system. Thank you for watching. Please subscribe if you still haven't, and share this video with people that you think may learn something from this. And in the next video, we're going to talk about something else related to space, sciences, or math, and you're going to learn something else again. And don't forget, you can also support this channel on Patreon, and this does help me with various purchases of various cool equipment that will make my videos even better. Thank you for everything, guys. I'll see you in the next video. Game you later, and as always, bye-bye. And this is now totally and absolutely hot and molten. Welcome to New Earth, Earth of the future.